All right, we're doing section 8.3 with two new properties, including the zero exponent and negative exponent. So let's start with the zero exponent property. If we have a base of a raised to the 0 power, it is 1. So it doesn't matter what the base is. It could be 7, that's still going to be 1, or 29 to the 0, that's still going to be 1, or negative 8 to the 0, that's still going to be 1. So anything, no matter what your base is, if you raise it to the 0 power, it's going to be 1. Okay, now we're going to do the negative exponent property. A to the negative n is the reciprocal of a to the n. That means if we start with a to the negative n, reciprocal, we just do 1 over a to the n, because we never want to have a negative exponent in our answer. So we're going to do whatever we need to do to change the negative exponent to a positive. In this case, putting it underneath the fraction is what we do. So if we start with 3 to the negative second, to make it positive, it's 1 over 3 squared. I would rather you keep it as 1 over 3 squared than 1 over 9, because I know you can just type that in your calculator, and I want to know that you know the property to make it the reciprocal. B, negative 7 to the 0, that is the zero exponent property. That one's just going to be 1. C, we need to make the reciprocal 1 over 1/5 quantity squared, and now I need to distribute that squared. That's the property from section 2, 1 over 1 squared over 5 squared. Now we have division here involving fractions, and we can't divide fractions, so we have to multiply by the reciprocal. The reciprocal of the bottom is 5 squared over 1 squared. That's the same thing as dividing. So we can actually just simplify that, because 1 squared is just 1. We don't need to write that. So our final answer is just 5 squared. D, 0 to the negative 5th, we change that to 1 over 0 to the 5th. And that would just be 1 over 0, which we can't do. That is undefined. E, 2/3 to the 0. Anything to the 0 power is 1, so that one is just 1. F, 1 over 2 to the negative 3. It goes the other way as well. If you start with a negative exponent on the bottom of your fraction, you can bring it up to the top and make it positive. So that's 2 to the 3rd. Okay, I'm going to recap all of the properties that we've used so far. In section 1, we used this property where if we multiply two numbers with like bases, we add the exponents. Second one, if we have a to the m and we raise the whole thing to the nth power, then we multiply the exponents. If we have a product and we raise it to a power, then we distribute that power to everything in our parentheses. If we have a quotient, we subtract the exponents if we have like bases. And if we have a quotient, the whole thing being raised to an exponent, we distribute that exponent into everything, including the bottom. Okay, so we just wanted to recap those since we are going to use them in the examples below, just to remember. A is our first one where we add the exponents. 6 to the negative 4 plus 4 is 6 to the 0. Everything to the 0 power is 1, we just learned. B, we multiply the exponents, so that's 4 to the negative 4. We can't leave our answer with negative exponents, so it's 1 over 4 to the 4th. C, if we start with a negative exponent on the bottom, we have to bring it up to the top, make it positive, so that's 3 to the 4th. And D, there's a couple of ways to do this. We can either do the subtraction, so we just subtract the exponents, negative 1 minus 2, just 5 to the negative 3, or 1 over 5 cubed. Or the other way to do it, I'll rewrite the problem and show you the other way. You can bring that 5 to the negative 1 down to the bottom, make it 1 over 5 to the first times 5 to the second, and then you get 1 over 5 to the third about the same number of steps, so whichever one you prefer. Now we're going to use all of our properties here. We distribute the 3 into every term, so it's 2 to the third, x to the third, y to the negative 15th. Remember, when it's a problem with numbers and variables, you want to simplify just the number, and we also need to move the y to the 15th to the bottom to make it positive. So this would be 8 x to the third over y to the 15th. B, we need to distribute our exponent on top. So that's 2 to the negative second, x to the negative second, y to the fifth over negative 4 x squared y squared. And then we have 2 negative exponents we need to move down to the bottom. So all we have left on top is y to the fifth. On the bottom it becomes 2 squared. That was times negative 4. Then we have that x squared. We have the x squared that was already down there, and y squared. So now we need to combine all of our like terms and simplify. On this top we still just have y to the fifth. On the bottom, 2 squared times negative 4 is negative 16 times x to the fourth y squared. And we have the y's that we can cancel now. We subtract the exponents, so all we have left on top is y to the third. On the bottom is negative 16 x to the fourth. And our last word problem. If we have the order of magnitude of the mass of a polyphemus moth larva when it hatches is 10 to the negative 3 grams, it can eat 10 to the fifth times its own mass in food. How many grams of food can it eat? So we take how much it weighs and multiply it by how much it can eat to figure out how many grams it can eat. So we need to add the exponents. It's 10 squared or 100 grams of food. And that was it for section 3.